Welcome to 10.2. We are going to look at an in-depth study of the parabola. Our objectives for this section are to analyze parabolas with vertex at the origin, analyze parabolas with our vertex at a different point than the origin, and solve applied problems that involve parabolas. Over here on the side, I included a diagram of the parabolas just so that way we know the vocabulary we're using. We can see right here at the most bottom or most top point, that will be our vertex, which is labeled HK. We can see the directrix spans from D1 point to D2 point. And notice that the D1 is the length from our focus to this point x1, y1, which is the same length from this axis. It's the same distance from the axis to our parabola and from our parabola to the directrix. So those two values are the same distance. Again, D2 is the same. We can see that same thing happening. Some other things, let's see. Our axis is where it goes through the vertex. And yeah, I think that's all of our major points that we're going to be talking about in this section. So let's look at some examples. Find the equation of the parabola described. Find the 2 points that define the latus rectum. Okay, so it's another one of those almost riddles where they're giving us a bunch of characteristics and we need to find out what the equation is. They're telling us our focus is at 7, 0, and our vertex is at 0, 0. So first, let's start with a general equation. We are going to start with y squared equals 4ax. And if you're unfamiliar with where this is coming from, please reread this section of the text and do the guided notes. It walks us through where we should be getting this general form. In this case, because they gave us the focus, we know that a is 7. So let's plug that in. We're going to have y squared equals 4 times 7x, which gives us y squared equals 28x. And that is our equation. Now our second part, they want 2 answers. So our first one was find the equation. The next one is find the 2 points for the latus rectum. So now we're going to work on that second piece. We have our equation. Let's do y squared equals 28x. Let's substitute in x equals 7. So we will get y squared equals 28 times 7, which gives us 196. And that's y squared, so we just want y, which gives us plus or minus, if we take the square root, we'll get 14. So when x is 7, our y value is positive 14 and negative 14. So those are our 2 points, 7, 14, and 7, negative 14. There we go. Okay, this one's telling us our focus is at 0, -1, and the directrix is the line y equals 1. So let's start with our general form. We're going to have x squared equals -4ay. And in this case, we have our directrix is the line y equals 1. That's telling us a is 1. And so x squared equals -4y is our equation. Now let's find those 2 points for the lattice rectum. We'll start with x squared equals -4y, and what we'll do is we'll substitute in that y equals -1 because that's what we were given. And if we substitute that in, we're going to get x squared equals -4 times -1, which is 4. And taking the square root, we'll get x is positive and -2. So when y is -1, x is 2 and -2. Those are our 2 points. So we have 2, -1, and -2, -1. Okay. We have the directrix x equals -1/7, and our vertex is at the origin. Let's start with our general form of an equation. Y squared equals 4ax. It's telling us a is -1/7. So if we plug that in, we get y squared equals -4/7 x. Next, we'll find those 2 points. So we will take our general equation, y squared equals -4/7 x. We'll substitute in x equals -1/7. That's what we see right there. And that will give us y squared equals -4/7 times -1/7, which gives us 4/49. And if we take the square root, y is ±2/7. So our 2 points are when x is -1/7, y is 2/7, and it's also -2/7. There we go. Okay. Oops. This one tells us the vertex is at the origin, the axis of symmetry is the y-axis, and it contains this point 5, 3. So we'll start with our general form of equation. X squared equals 4ay. And we're going to substitute in our point 5, 3, because that point has to be on this graph, and then once we plug in an x and a y value, we can solve for a. So we have 5 squared equals 4a times 3. This gives us 25 equals 12a. So a is 25/12. Now we're a little bit closer. So we had x squared equals 4. Now we know what a is, so a is 25 over 12 y. And 4 over 12, we can simplify that, so the 4 reduces with the 12. So if we reduce each of those by 4, then we're left with x squared equals 25 over 3y. And there's our equation to get our 2 points. We will use some information that we need. We know we can determine our focus, and we can determine the focus by 0 and 25 over 12. Because our focus is the A. If you need to refresh, go back to all of the breakdowns. There are a couple very helpful tables in this section that break down the focus, the directrix, and the vertex, and all of the really important points on the parabola in terms of the A's that we're looking for. And then when we get to the other examples, we'll even talk about the H and K as well. So our focus is 0, 25 over 12, and our directrix is y equals negative 25 over 12. So using this information, we can find our 2 points. We'll use x squared equals 25 over 3. And pulling from our focus, we have 25 over 12. And so this will give us 25 squared over 36. I'm going to leave it squared right now. I'm not going to multiply that out, only because I know I have to take the square root. So if I take the square root to find out what x is, that will give me plus or minus 25, right? The square root of 25 squared is just 25. Square root of 36 is 6. So when y is 25 over 12, that means x is positive and negative 25 over 6. So we'll have 25 over 6 and 25 over 12. Also, negative 25 over 6 and 25 over 12. Next step, let's find the vertex, focus, and directrix for each parabola. So here we're given y squared equals 4x, and using that we're going to find all of the characteristics. So first of all, we can label our A as 1. And looking at the characteristic table in the textbook, I can see that following, when I have a function that looks like this, my vertex is at the origin, my focus is at 1, 0, because my A value is 1, and my directrix is x equals -1. And the absolute best way to double check that you're getting these things on the right track is graph it. Put this equation into your graphing calculator or into Desmos and double check that, yeah, the vertex is at 0, 0, the focus is at 1, 0, the directrix actually is at x equals -1. All these things are there. Just double check your work. Okay, now we have x minus 5 squared equals negative x plus 1. I mean y plus 1, I'm sorry. So first we are going to write out that I'm going to label that this value right here, this 5, is our h, and that this value, the 1, is our k. And since it's y plus 1 and the formula is y minus 1, then that means k is a -1 because the sign is flipped. This tells us our vertex, which is hk, is at 5, -1, and then our focus is at 5, and then our second value is actually k minus a. And so we need to know what our a value is. In this example, our a, we're going to look right here. Usually we have 4, right? And we don't see that there, so we know that it had to be divided by 4. There's also a negative, which tells me it's a -1/4, because the 4 is a -1 now. So, knowing that, that tells us that our focus is at 5 and -5/4, because that would be k minus a. Our directrix is y equals, and for this one we're using k plus a, which gives us -3/4. So that's the line that is the directrix, y equals -3/4. Okay, this one, y minus 3 squared equals 12, x plus 1. Here, we can see that the 4 has become a 12, which tells us a is a 3, because 3 times 4 gets us to 12. We also know h and k. Now be careful, because this time our x and y are switched, and so this is our k value and this is our h value. Always be aware of what exactly you're looking at. And so our vertex, which is hk, is going to be -1, 3. Our focus, which is h plus a, and k, so that's 3. H plus a gives us 2, 3, and our directrix gives us x equals, And this time we're looking at h minus a, which would be -4 if we take our h minus a. Okay, let's find our characteristics of this one here. Now this one's put together in a different format, but we can move things around so that way it's easier to find these characteristics. So the first thing I'm going to do, since it's y squared minus 10y plus 4x plus 25 equals 0, I'm going to move the x to the other side. So if I subtract 4x, we'll have y squared minus 10y plus 25 equals -4x. Now I can factor this side. Y squared minus 10y plus 25 is y minus 5 squared. Now the other side I didn't do anything to, it's going to stay. It's going to stay the same. And now I'm going to rewrite it one more time. Y minus 5 squared equals -4, and then we have x minus nothing. It's just x over there. But this format will help me see that I have a -4, so a is 1. I have -5 here, so my k is 5. I have a 0 here, so h is 0. So putting it into this format allows us to point out those characteristics a lot easier. This shows us our vertex is at 0, 5. Our focus, following the same format, we're going to put h minus a here and our k. So we've got h minus a gives us a -1, 5. And lastly, our directrix is going to be x equals the h plus a, and h plus a is 1. Okay, an application problem to finish us off. A searchlight is shaped like a paraboloid of revolution if the light source is located 2 feet from the base along the axes of symmetry and the opening is 10 feet across. How deep should the searchlight be? So what are we even looking at here? We're looking at a light that has a paraboloid revolution. It's telling us the light source is located 2 feet from the base. So if the base is down here, if we go up 2 feet, the light source is here. So we have this little light bulb here, and it's giving off light. Let's see. There's our light source. And it's 2 feet from the base, and the opening is 10 feet across. So from here to here, we have 10 feet. So that's what our light is looking like. If we make it more graphical, it would be something like this, our paraboloid. If we are 10 feet across, that tells us that from our origin to here, it's got to be a 5, and to here, it's got to be a -5. So it goes from 5, from that axis, it goes up to 5. is what we're looking at. Of course, we know that parabolas go forever, but in this particular case, we're only interested up to 5. And then we know that we have our light source up here at 2. So what I'll do is here we have some points of interest. This is 0, 2. This is 5, and that missing number n. I guess we'll label it D for deep. Like, how deep are we going into this light? How deep is the searchlight? And over here we have -5 and that same distance, right? We want to know how deep is the searchlight. Well, it's the same amount on both sides. It's not deeper on one side than the other, so it's going to be the same value on both sides. Usually when I draw a picture, it really helps. So I hope this helps you too. Let's start with our general equation. X squared equals 4ay. Our focus, which is our light source, is 0, 2. What does this tell us? This tells us our value of a is 2. So let's make our general equation a little bit less general. X squared equals 4 times 2 times y becomes x squared equals 8y. Now that we have our equation, and we also know that 5, D is on the graph, then we know that when x is 5, y is that missing value d. And this is exactly how we can solve for that missing variable. So we have 25 equals 8 times d. So if we divide by 8, we get 25 over 8. So the searchlight is 25 over 8 feet deep. And that's it. Using what we know about our parabola, we were able to solve an application.